Now we're going to take a closer look at graphing those quadratic functions. The standard form again is going to be y equals ax squared plus bx plus c. And this a, b, and c, those are going to be numbers. So it might look something like, let me give you an example, y equals 2x squared minus 3x plus 1. There'll be numbers in there. But again, that x squared being our highest degree designates it as a quadratic and would graph a parabola. So let's talk about some other things. Reviewing this again, the direction of the opening of my parabola when the a leading coefficient is greater than 0, which means it's positive. You have a positive value there. Remember, it makes a smiley face, or you have it opening upward. If your a value is less than 0 or negative, remember your parabola is going to look like a frowny face, or it is opening downward. Now, the axis of symmetry. In the last lesson, we looked at the graph and visually identified where the axis of symmetry was. But if you're just given the function without a picture, without the graph, you can find the axis of symmetry using a formula. The formula is x equals, because that's going to give us our equation for our axis of symmetry, negative b over 2a. So you would take whatever value is in the b spot in your function and whatever value is in your a spot, and you would plug it into this formula. Negative, whatever the b value is, divided by 2 times a, and evaluate, and that would tell you your axis of symmetry. Your vertex. Again, in the previous lesson, we just looked at the graph and identified the vertex, but if we're just given the function, what do? Well, you can take your axis of symmetry value and plug it in to the given function. So plug in the x value, which is your axis of symmetry, into the function, the y equals quadratic function that you're given, plug it into the function to find y. And then you pull it together to make your ordered pair for your vertex, your x value from your axis of symmetry and the y value that you just solved for. That'll tell you your vertex. So let's start putting it into action. Let's look at an example. Number 1, graph the equation y equals x squared minus 6x plus 5 on the accompanying set of axes. You must plot 5 points, including the roots. Now remember, roots is our x-intercepts. So I've got to add those x-intercepts and the vertex. And then delta math is going to create the parabola for us. But we have to have 5 points. 2 of them have to be roots, or the x-intercepts, and 1 has to be the vertex. All right, let's start with, what do we already know? We've got y equals x squared. There's an understood 1 right there, an understood positive 1, minus 6x plus 5. So there's my a value. This is in our standard form, ax squared plus bx plus c. 1 is my a value. So this is going to be positive and a happy smiley face parabola. I already know that. I'm going to go ahead and list my a value, like I said, is 1. My b value is going to be negative 6, and c is 5. You see how those line up there? A was 1, b is negative 6, and you do use that sign, and c is 5. So I already know it's a smiley face positive parabola. And so let's start with finding the axis of symmetry. That's our first question below. Determine the equation for the axis of symmetry. We're going to use the formula x equals negative b over 2a. So let's fill that in. The formula is a negative, and then my b value. B is negative 6. So I'm going to have a negative 6 over 2 times a was 1. And evaluate. So 2 negatives make a positive 6 over 2, which is going to simplify to 3, or my axis of symmetry is at x equals 3. I'm going to go ahead and add that to our graph. I'm going to make a vertical line down here along x equals 3. I don't know where my parabola is yet. Now let's find the vertex. So to find the vertex, I'm going to take that 3 and plug it into our function. Our function was y equals x squared minus 6x plus 5. And I'm going to plug in that 3 in place of x. So 3 squared minus 6 times 3 plus 5. 3 squared is 9. Negative 6 times 3 makes negative 18 plus 5. So I'm going to get negative 4, or my vertex, was 3, negative 4. I got the 3 for the x value from my axis of symmetry. We plugged it into the function, and we equaled negative 4, which is my y value. So 3, negative 4, going to my graph, plotting my vertex. Now, the last question we have on our notes here is determine those roots or those x-intercepts of our equation. Well, we still need to build the rest of our graph. So if you want to graph by hand, I'm going to go ahead and tell you your parabola shape is based on a 1-3-5 rule. It's not mathematically special. This is just a really good trick for graphing parabolas. So your parabola shape, I'm going to make a note up here. We're going to call it the 1-3-5 rule. So we're going to take our a value from our function, because your a value can determine whether it's up or down, smiley face or frowny face, and whether it's been stretched or compressed. So it does dictate a lot about our shape. And we're going to take our a value and multiply it times 1, a value times 3, and our a value times 5, and it's going to help us create the shape of our parabola. So for this one, the a value was 1, remember? So this is just 1 times 1 is 1. 1 times 3 is 3. And 1 times 5 is 5. So since my a value is 1, this parabola has not been shifted, changed, stretched, or compressed. It's got a very basic parabola shape. It still has that parent function shape of 1, 3, 5. So using 1, 3, 5, I'm going to go to the right one, up 1. I'm going to go to the right 1, up 3. 1, 2, 3. I'm going to go to the right 1 and go up 5. 1, 2, 3, 4, 5. Now, parabolas are symmetric, right? So I'm going to go the other direction. Over 1, up 1. Over 1, up 3. Over 1, up 5. And that's going to give me my basic shape, and I can connect my dots to create this parabola shape. Now, the other method you can use to create points for your parabola is just plugging in values. You could have plugged in, since our vertex is at 3, you could have plugged in 4 to see what your y value is to create another point. Then you could have plugged in 5 into the function to evaluate where another point is, and so on and so forth. But the 1-3-5 rule does work. You just always have to multiply it with your a value. We are also going to graph on our calculators here in a minute, and so that can help you as well. So let's finish up our question at the bottom. Determine the roots of our parabola. Our roots are our x-intercepts. So we have got 2 of them, and we're going to write them as ordered pairs. So this first one is at 1, 0, and the second one is at 5, 0. So let me list that down here on our notes. 1, 0, and 5, 0 are the roots or x-intercepts of that equation, x squared minus 6x plus 5 equals 0. All right, so let's take a moment and actually graph this one. You can see you've got all of those Inspire calculator steps on the right. So let's walk through how would you graph number 1 and maybe save yourself some time. Let's start with, from our home screen, we will choose a new document. And if you have something there, it's going to ask if you want to save. No, I don't need to save. And we're going to add a graphs page. You're going to type your entire equation. So it was y equals, start with the x squared minus 6x plus 5, and hit enter, and you can see that lovely parabola has been graphed there. Now the next thing you have here on your list of calculator steps is to identify ordered pairs. One thing you might want to do is turn on your grid lines. I don't have that here on your notes. To do that, go to menu, view, number 6 is grid, and I would like a lined grid. And that can help you identify your ordered pairs if you are crunched for time, like on an end of course test. So that can help me identify ordered pairs. But another way is do menu. Number 7 is table. The first option, the only option, is a split screen table. And that can give you your list of x's and y's. Notice here in the left column, the x values, 1, and then the y value would be 0. 1, 0 was an ordered pair on our graph. In fact, we listed it as one of the roots or x-intercepts. 2, negative 3, 3, negative 4, 4, negative 3, and so on and so forth. So then you can scroll through here and find ordered pairs. So you can graph it that way. Now, okay, I'm done with the table. Table, go away. To remove the table, you're going to go to menu. Notice my menu is different. Number 2 is table and remove table. Easy as that. Okay, what if I can't identify the vertex? Right here, I can kind of use my grid lines to help me pick it out and identify it, but maybe it's a little bit messier. Maybe it's actually a decimal place. So to find your vertex, which could also be called your minimum or maximum, you're going to go to menu, analyze. Now you're going to have to identify, is this a minimum or maximum? We had a normal smiley face. So that's my lowest part. That vertex is my minimum. And you're going to have to identify a lower bound and upper bound. Here's what's going on. The calculator is going, I'll find you your minimum. But this is a graph that goes on for infinity. So if you'll just tell me where you're looking, I'll be glad to help you. So lower bound just means, hey, tell me like the lower side or left side. And then it's going to ask us for the upper bound or the right side. Give me a range where you're looking and I'll find it for you. So I'm going to just slide this dashed line just on the left side. You don't have to be super, super close to it. You don't have to be way out here, just anywhere on the left side. Now, if you use the keypad, you can stroke across the touchpad and move that dashed line, and then you're going to hit the center enter. As soon as I hit enter, it's going to switch to upper bound. And it's waiting for me to put my dashed line on the other side, just creating this range where I'm looking on the graph. So again, anywhere you can already see it's starting to identify my minimum. It's already got the vertex labeled there 3, -4. But I'm going to hit OK or my center button, and it has labeled it there 3, -4 as my vertex. To find your zeros, your roots, your x-intercepts, you can do the same steps. Menu, analyze, and on there they have zeros. So these are our x-intercepts. Again, it's going to say, hey, where are you looking? In fact, this parabola has 2 of them. So tell me which one you want me to identify first. So I'm going to slide over to the left and hit OK, that center button. Slide over to the right, and you can see it's already starting to identify that first 0 of 1, 0. And so I hit enter and it's got it labeled. I'm going to walk through those steps again. Menu, analyze, 0, left side, okay, right side, 5, 0. It's already identifying there. There is the zeros of our roots or our x-intercepts of our parabola. So let's say the parabola is hard to see. Maybe it's kind of off the graph a little bit. Maybe it's a little bit high. Man, I need to be able to see my parabola better. You can take your keypad and wherever your mouse is indicated, if you hold down that center button, let me see if I can get it. There we go. If I hold down the center button, it's going to turn to a grab, and then I can move using the touchpad. So if you ever need to move your graph around, you can do that, and then you just hold the button again to release it back to a cursor. Okay, let's say I am done with this function. I'm done with this graph. I'd like to start a new one, or maybe I made a mistake. Maybe I mistyped the function into the calculator. You can hit tab, and then you'll need to arrow up if you need to edit the previous one. So you can see there we've got in the box x squared minus 6x plus 5, where I could fix it. If you're going to do a whole new graph, what I would suggest is instead, I'm going to hit escape. I would do Control I to insert a new page, an entire fresh start, and I can add a new graph. And it's going to create a new tab up there at the top. Now it's 1.2, a whole new graph for me to work with. You can also toggle between your tabs, say, oh, I want to go back to that last problem. Control and the left arrow will take you back to that previous graph or that previous tab. So let's use the calculator and let's do number 2 and number 3 together on the calculator. I'm going to go to my new tab. I'm going to do Control right to go to that new page that I just opened. And I'm going to type in my function, negative x squared minus 4x plus 5. Hit enter to graph it. Let's say I want to put my grid lines on. So view, my grid, and lined grid is 3. A little hard to see, so I'm going to move my cursor up here. I'm going to hit the grab tool and then pull it down a little bit. Now I can see all the pieces that I need. I'm going to release that. Let's find our axis of symmetry. So I can just look at my graph and see that it is crossing at -2, x equals -2. I'm also going to graph it on our notes here. So our axis of symmetry, x equals -2, I could just see that from my graphing on the calculator. Make a note here on our notes that we have graphed it on our calculator in case anyone just looks at the notes. All right, what about that vertex? So I'm going to walk through the steps. I know I can probably count my grid lines right here, but I might miscount it. So let's do menu, analyze graph. This is going to be a maximum. This is a height. So I'm going to do 3 to identify the maximum. I'm going to slide over to the left side and hit center OK. Slide over to the right side, hit that center OK. It's identified it as -2, 9. Adding that to my notes here, -2, 9 is our vertex. All right, what about the roots or x-intercepts or zeros? All of those terms mean the same thing. I'm going to go to menu, analyze, zeros. Again, slide over to the left side. There's 2 x-intercepts. So I'm going to help the calculator out, let it know where I'm looking. So it's got the left side there. I'm going to walk through those steps again. Menu, analyze, zeros. I'm already on the left side of that second one. Hit OK and then slide over. You can see it starts to identify really quickly our 2 roots for our equation, -5, 0, and 1, 0. Add that to our notes here, -5, 0, and 1, 0. Now I need 2 more points, so I can also use that table to help me out, right? Menu, table, split screen table, and that can help give me another set of ordered pairs. It looks like I could also plot a 2, -7. So I could add down here. It would also reflect, so there's probably a -6, -7 as well. If I arrow up, there's also a 0, 5. We should see a -4, 5. Let's check out our table. Yep, -4, 5. There was also -6, -7. So this table is really helpful to identify additional ordered pairs. So let's connect our points to create that upside down parabola. Try to make it nice and smooth like a curve. Let's do number 3 as well. So I'm ready to start a whole new page. I'm going to do Control, Insert, Add Graphs, and it's going to give me a 1.3, and I'm ready to type in 2x squared minus 8x plus 6. Hit Enter. All right. I need to plot 5 points, including our roots and our vertex. Let's start with that axis of symmetry. Let me turn on the grid lines. View, grid lines, lined grid. I can see it's over there at +2. That's pretty easy. Let me put that on our graph. Let's use the table. Let's do menu 7 and that split screen table. And maybe this will be a faster way on some of your problems. So we've got 1, 0 is one ordered pair. 1, 0. We've got 2, -2. That's going to be my vertex. And 3, 0. 2, -2, and 3, 0. How did I know 2, -2 would be my vertex? Because it's right there on that axis of symmetry. Your vertex will always be along that axis of symmetry because that's the center or middle line of that parabola. Let's get one more set of ordered pairs. We could also add in 4, 6, and I think, yep, there's also a 0, 6. So 0, 6 right here on our y-axis, and then also 4, 6. So I've got those 5 points where if I was on Delta Math, it would graph it for me, creating that nice parabola curve there. Let's add to our notes. The vertex was 2, -2, and the roots, those are our x-intercepts, of our equation 2x squared minus 8x plus 6 equals 0. Looks like it's going to be at 1, 0, and 3, 0 are the x-intercepts or the roots of the related equation. The last part of our notes is multiple choice. And do not worry, we don't even need the calculator for this. I wanted to show y'all a couple examples on our notes and in our video here of how you can use like deductive reasoning and things that you already know to match these graphs. So we can see we already have a nice, happy, smiley face parabola. I know my A value is going to have to be positive. The beginning of the function for this graph is positive. So as I look at my answer choices below, I know it's not these last two that have a negative 0.8 at the beginning. Cross those out and done. The other thing you can use is y-intercept. Our y-intercept right here, where our graph is crossing the y-axis, that's at 0, -7. That's also going to be the c value or the constant in our function. So the last two answer choices we have left have a -7 or a -7.3. I'm pretty confident it's passing through just -7. I think it is the first answer choice. Let's look at another example and call it a day. We've got an upside down frowny face parabola. I know that a is less than 0 or it's negative. So the beginning of this function would start with a negative. Again, I'm going to eliminate these last two answer choices and then check out where it's crossing the y-axis. It looks like it's crossing the y-intercept at 0, -6. So I'm going to check out my last constants here. Those do represent our y-intercepts. It's not 0.9. It's this answer choice, -0.9x squared minus 5x minus 6. So those are pretty easy. Do not worry about trying to graph those because you can use the other things that you know about functions to eliminate your answers. So that's graphing quadratics. Guys, you will be asked to do some graphing on benchmarks without calculators or answer questions that can't be answered using a calculator. So do take some time to find your axis of symmetry using that formula -b/2a, or know how to identify your vertex giving a function. But we can use the calculator a lot to help us graph. We did that on 2 and 3. We specifically only used the calculator to finish examples 2 and 3 here to identify our axis, vertex, and the roots, which are our x-intercepts. Practice those, guys. Get comfortable with those calculators. They are amazing tools. Guys, let me know if you have any questions, and I'll see you in class.